Have you ever stopped to think about where the very concepts that underpin our daily digital lives actually came from? You know, the idea of a computer that can think,
Mhm.
maybe, or logging into a system that feels like it's all yours, even though loads of others are using it at the same time. Well, today we're taking a deep dive into the mind of one of the true architects of our modern digital world, John McCarthy. Our mission today really is to unpack how this one visionary individual not only came up with the term artificial intelligence itself, but also, laid the groundwork for how we actually interact with computers. Everything from programming languages to, well, the cloud computing we all rely on now.
Right. And what's so fascinating about McCarthy, I think, is that he holds this really unique position. He wasn't just a theorist thinking about abstract stuff like intelligence. He was also a hands-on engineer building the actual infrastructure, the computing systems that made a lot of those ideas even possible. So his influence, it really goes from like deep philosophical thought all the way to the tangible tech we use every single day.
Okay, so to really get a handle on this incredible mind, let's start at the beginning. John McCarthy, born in Boston, Massachusetts, September 4th, 1927.
Yeah.
And he had quite a diverse background, didn't he? An Irish immigrant father and a Lithuanian Jewish immigrant mother.
Yeah, and his childhood growing up during the Great Depression seems pretty formative. His parents were active members of the Communist Party back in the 1930s. And that kind of environment, well, it really fostered this emphasis on learning, on critical thinking. You can see how it might have shaped his early intellectual curiosity.
Oh, definitely. And speaking of that curiosity, here's a pretty amazing detail. McCarthy apparently taught himself college-level math while he was still a teenager. He just studied textbooks from Caltech nearby.
That's the story. And it meant that when he actually got accepted to Caltech, he managed to skip the first 2 years of their math program.
Wow. Though his path there wasn't exactly smooth sailing, was it? Already got suspended for skipping PE.
Yeah, physical education wasn't his thing, apparently. But he still got his Bachelor of Science in Mathematics in 1948.
And Caltech was where he had a really key moment, right? Something involving John von Neumann.
Exactly. He attended a lecture by von Neumann, the, brilliant mathematician and computer pioneer. And that lecture apparently just, boom, sparked his interest and profoundly inspired his future work in computing and AI.
So after Caltech, where did he go?
He finished his graduate studies there, then headed to Princeton for his PhD in mathematics, which he got in 1951. Donald C. Spencer was his supervisor.
And his academic career took him to quite a few places.
It did. Short stints back at Princeton, then Stanford. He became an assistant professor at Dartmouth in 1955, then moved to MIT in 56 as a research fellow. Apparently, his students there called him Uncle John.
Uncle John, really?
Yeah. Then in 1962, he became a full professor back at Stanford, and that's where he stayed until he retired in 2000. And throughout his career, he was a real champion for using mathematical logic in computing, things like lambda calculus.
Lambda calculus. Can you just quickly unpack that?
Oh, sure. It's essentially a formal system in mathematical logic for expressing computation based on function abstraction and application. Think of it as a really fundamental, powerful way to define what computation is using functions. McCarthy saw its potential for programming.
Right, okay. So with that foundation laid, how did we get to the actual term artificial intelligence? How did that field get its name?
Well, that's where McCarthy really takes center stage. He was one of the key figures. He co-authored the proposal document that first used the term artificial intelligence, AI.
And this was for that famous Dartmouth Conference.
Exactly. The summer of 1956, McCarthy, along with Marvin Minsky, Nathaniel Rochester, and Claude Shannon of information theory fame, they wrote the proposal for this workshop. And that event, that proposal, is pretty much universally seen as the official starting point for AI as its own academic field.
And didn't that proposal have this incredibly bold, almost audacious statement right at its core?
Oh, absolutely. It's quite famous. They stated, and I'm paraphrasing slightly, that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it.
Wow. That's quite a claim for 1956.
It really was. I mean, incredibly ambitious. But that vision, that statement, it really did set the agenda. It fueled decades of research and helped establish AI as a legitimate field you could actually study and work in.
Okay, so the field has a name, but it needs tools, right? It needs a language to actually build these thinking machines. How did McCarthy contribute there? How did he give AI its voice, so to speak?
Well, he did that with LISP, LISP stands for list processing. He developed it in the late 1950s, and it was published in 1960.
LISP, I've definitely heard of it. What made it so special for AI?
Okay, so Lisp was groundbreaking for a few reasons, but maybe the most fundamental, the most radical idea was that in Lisp, code itself is treated as data.
Code is data. What does that actually mean?
It means the program's instructions, the code, could be manipulated, changed, even generated by the program itself while it was running. Think about that. Programs that can write or modify other programs or even themselves. This concept, sometimes called homoeconicity, was just mind-bending at the time and absolutely crucial for AI for building systems that could learn and adapt.
Okay, that does sound pretty powerful. And it introduced some key programming concepts too, didn't it? Like recursion.
Exactly. Lisp made heavy use of recursion functions, calling themselves, which is great for tackling complex nested problems often found in AI. It was also built for symbolic computation, manipulating symbols and concepts, not just numbers, perfect for representing knowledge.
And garbage collection. That sounds messy.
Huh. No, it's actually the opposite. Garbage collection was this brilliant innovation for automatic memory management. Before Lisp, programmers often had to manually keep track of computer memory, allocating it, freeing it up. It was tedious and error-prone. Lisp's garbage collection automated that whole process. The system automatically figured out what memory was no longer needed and reclaimed it. It was a huge productivity boost.
And lambda calculus played a role here too.
It did, yeah. The underlying mathematical principles, the semantics of Lisp, were heavily influenced by that lambda calculus we mentioned earlier. It gave Lisp a really clean, powerful, theoretical foundation.
So Lisp wasn't just some historical artifact. It's still around.
Oh, yeah, definitely. While it might not be the most common language for, say, web development today, it's still highly influential. You find it and its dialects in specialized areas, particularly in AI research, robotics, and also in the broader field of functional programming.
Functional programming.
It's a style of programming that emphasizes using functions in a way that's closer to their mathematical definition, avoiding changing state and mutable data. Lisp was one of the earliest and most important functional languages.
And Lisp wasn't his only contribution to programming languages, right? There was LGOL too.
That's right. He didn't invent LGOL 60, but he had a significant influence on its design. He was the one who proposed including recursion and also conditional expressions like if-then-else structures, which became fundamental parts of LGOL and, frankly, most programming languages that followed.
Okay, let's shift gears a bit, because McCarthy made another huge contribution, one that maybe doesn't get highlighted as much as AI or Lisp, but is arguably just as impactful on our daily lives. Time sharing.
Yes, time sharing. It's hard to overstate how revolutionary this was.
So what was the world like before time sharing?
Well, think about computers back then. Huge, incredibly expensive mainframe machines. The way most people interacted with them was through batch processing. You'd punch your program onto cards, hand the stack of cards to an operator, and then you'd wait hours, maybe even days. Eventually, you'd get your printout back. There's no interactivity, no back and forth.
That sounds incredibly slow and frustrating.
Exactly. McCarthy saw this inefficiency. Time sharing was his solution. The core idea was to let multiple users connect to the same mainframe simultaneously, each through their own terminal. The computer would rapidly switch its attention between users, giving each one a small slice of processing time. It happened so fast that it appeared to each user that they had the machine all to themselves.
So it created the illusion of simultaneous interactive use.
Precisely. It turned the computer from this remote, slow batch processor into something interactive and immediately responsive. It was a fundamental shift in how humans interacted with computers.
And he was directly involved in building some of the first systems.
Absolutely instrumental. He played key roles in developing three of the earliest, most influential time-sharing systems: CTSS at MIT, the BBN time-sharing system, and the Dartmouth time-sharing system.
His colleague, Lester Ernest, had a really powerful quote about this, didn't he? Something about the internet.
Yes, it's a great quote. Ernest said basically, the internet wouldn't have happened nearly as soon as it did, except for the fact that John initiated the development of time-sharing systems. He went on to say, we keep inventing new names for time sharing. It came to be called servers. Now we call it cloud computing. That is still just time sharing. John started it.
Wow. So servers, cloud computing. It all traces back to McCarthy's time-sharing concept.
That's the argument, and it's a strong one. The fundamental idea of sharing centralized computing resources among many users remotely, that's time sharing.
And he even predicted the business model, didn't he? This utility computing idea.
He did, way back in 1961. He publicly suggested that computer time, through these time-sharing systems, could eventually be sold like a utility. You'd just plug in and pay for the computing power or the specific applications you use, just like you pay for water or electricity.
That is astonishingly prescient. That's literally the model for cloud computing, software as a service.
Exactly. Decades before anyone else was really thinking that way, he saw the potential for computing to become this pervasive, accessible utility.
Incredible. Okay, so we've covered AI's name, its language, and the system that let us interact with computers differently. What about the deeper questions, the philosophy of AI? Did McCarthy delve into that?
No, absolutely. He wasn't just about building things. He thought deeply about the nature of intelligence itself, both human and artificial. A lot of his work involved using formal logic, mathematical logic, to try and capture common sense knowledge. How do we know the things we just know? How can we get machines to reason like that?
Like the advice taker concept.
Exactly. That was a paper he wrote in 1959. It proposed a hypothetical program, the advice taker, that could accept advice in formal language and use logical deduction to solve problems. It was really an early blueprint for what we now call knowledge-based systems or expert systems, AIs that rely on explicitly encoded knowledge and rules.
And he developed something called circumscription. What was that about?
Right, circumscription. This came later, mainly between 78 and 86. It tackled a really tricky problem in AI, reasoning with incomplete information. See, traditional logic is monotonic, meaning once you conclude something is true, it stays true as you add more information.
Okay, that makes sense.
But the real world isn't like that, right?
Yeah.
You often make assumptions based on what you currently know, and then you have to retract those assumptions when you learn something new. Circumscription was his formal method for this kind of non-monotonic reasoning. It basically allows an AI to assume the most normal or most typical state of affairs unless there's evidence to the contrary. It helps AI jump to plausible conclusions like humans do, even without all the facts.
That sounds vital for making AI practical. And what about his actual philosophical stance? Did he think machines could genuinely think or have beliefs?
He took a pretty provocative stance there, especially for the time. In a 1979 article called Ascribing Mental Qualities to Machines, he made this famous statement. He said, essentially, that even machines as simple as thermostats can be said to have beliefs, like a thermostat believes the room is too cold or wants to turn the furnace on.
A thermostat has beliefs. Seriously.
Well, his point was that having beliefs seems to be a characteristic of most systems, even simple ones, that are capable of goal-directed, problem-solving behavior. He was arguing for a functional definition. If it acts like it has beliefs in a way that helps explain its behavior, then maybe it does in a meaningful sense.
Okay, that's definitely a different way of looking at it. But there was pushback on that idea, wasn't there?
Oh, yes. Significant pushback. Most famously from the philosopher John Searle just a year later in 1980. Searle introduced his Chinese room argument.
Ah, the Chinese room. Can you remind us what that was?
Sure. Searle imagined himself inside a locked room. He doesn't understand Chinese at all. But he has a huge book of rules in English that tells him exactly how to manipulate Chinese symbols. People outside the room slide questions in Chinese under the door. He uses the rule book to find the right symbols and slides seemingly intelligent answers back out. Searle's point was, even though he could produce perfect Chinese answers, fooling anyone outside, he still wouldn't understand a word of Chinese. He'd just be manipulating symbols according to rules.
So the argument is that computers might do the same. They can process symbols and give intelligent-seeming output, but they don't actually understand anything. No real consciousness or intentionality.
Precisely. Searle argued that McCarthy's view, focusing just on the behavior, missed the crucial elements of genuine understanding and consciousness. It became, and still is, a really central debate in the philosophy of AI. We're presenting on both sides here, of course.
Right. A fundamental disagreement about what intelligence even means. Fascinating stuff. Now, beyond his core work, McCarthy seems to have had a really wide range of interests, some quite unusual.
Definitely. His curiosity seemed boundless. For instance, back in 1966, his AI team at Stanford played a series of chess games against a Soviet AI team.
An early AI chess showdown. How did they do?
McCarthy's team didn't win. They lost 2 games and drew 2, but it was a very early example of AI competition.
And then there was the space fountain. Chuckle slightly. Yes, the space fountain. This was an idea from 1982. It was a concept for a super tall tower extending way up into space. But instead of being held up by structural strength alone, it would be supported dynamically by a continuous stream of pellets shot upwards from the base, deflecting at the top and falling back down to be recirculated.
Okay, that is definitely outside the box.
It really showcases his engineering mindset, always thinking about novel solutions, even to massive problems like getting into space cheaply.
And he wasn't just locked away in the lab, right? He engaged with the wider world.
Very much so. He was quite active on Usenet, those early online discussion forums. He'd comment on world affairs, politics, all sorts of things. He even maintained a sustainability webpage where he argued that human material progress was both desirable and sustainable, countering some of the more pessimistic views at the time.
Interesting. And he was a strong free speech advocate.
Yes, very much so. Apparently, he even defended some controversial ethnic jokes circulating at Stanford, not because he endorsed them, but on principle, defending the right to free expression.
And didn't he have a very characteristic signature line?
He did, both on Usenet and apparently on his license plate cover. He who refuses to do arithmetic is doomed to talk nonsense.
Chuckles. That definitely sounds like, yeah, very logical, very direct.
Perfectly captures his mindset, doesn't it? And even late in his career, he was still exploring AI themes creatively. In 2001, he wrote a short story, The Robot and the Baby. It explored questions about whether robots should have emotions, and apparently it uncannily touched on aspects of internet culture and social networking before they really exploded.
Just briefly, touching on his personal life, he was married 3 times and faced some tragedy.
Yes, 3 marriages. His second wife, Vera Watson, who was a computer programmer and mountaineer herself, tragically died during a climbing expedition on Annapurna in 1978. And personally, he identified as an atheist. Politically, quite an interesting shift raised by communist parents, but he became a conservative Republican later in life.
Was there a specific reason for that shift?
Apparently, witnessing the Soviet invasion of Czechoslovakia in 1968 was a major turning point for him. John McCarthy passed away at his home in Stanford on October 24, 2011.
An incredible life, filled with groundbreaking work. And that work obviously didn't go unrecognized. He received numerous major awards, didn't he?
Oh, absolutely. He was showered with honors. The biggest one in computer science, perhaps, is the Turing Award, which he received way back in 1971 for his contributions to AI.
The Nobel Prize of Computing, essentially.
Pretty much, yeah. Then there was the Kyoto Prize in 1988, Japan's highest private award for global achievement, and the U.S. National Medal of Science in 1990.
He was also recognized by museums and institutions.
Yes, inducted as a Fellow of the Computer History Museum in 1999. Their citations specifically mentioned his co-founding of both AI and time-sharing systems, plus his major contributions to math and computer science. He also got the Benjamin Franklin Medal in Computer and Cognitive Science in 2003, and shortly before his death in 2011, he was inducted into the IE Intelligent Systems AI's Hall of Fame.
And we should also mention his role in founding the Stanford Artificial Intelligence Laboratory, SAIL, back in '65. That became a hugely important research center, right?
Definitely. SAIL was one of the leading centers for AI research for decades, attracting brilliant minds and producing groundbreaking work. McCarthy's influence there was immense. His work really did inspire generations of researchers who followed him. And right up to the end, he remained a staunch advocate for using logical reasoning, formal logic, as the foundation for AI, sometimes in contrast to the more purely statistical or data-driven approaches that became popular later.
So when you step back and look at it all, John McCarthy's legacy is just immense, isn't it? And so varied. A true architect of modern computing, of artificial intelligence, from the very name AI to LISP to time-sharing, which became cloud computing. His ideas are still profoundly shaping our world.
They really are. And there's that quote attributed to him by the Computer History Museum, which kind of sums up his maybe pragmatic and perhaps slightly provocative view on the inner workings of AI. He apparently said, "You don't want to examine the basis of your computer's morality any more than you want to see sausage being made."
Chuckles. Okay. That's a memorable way to put it.
Yeah.
So thinking about that, especially now in an era where AI is becoming so deeply integrated into our lives, and we're having all these debates about machine ethics, AI safety, alignment, what do you, listening right now, think of McCarthy's sentiment? How much do we want to know about the morality or lack thereof inside the intelligent systems we increasingly rely on? Something to think about.